Talk thanks. Yeah, recording in progress. Um, talk about some easy first steps, then talk about long-term improvement plans before we take a break. I think by the time we get through those first four things, we'll be ready for a break. And number 5 here, specific long-term options. There's a lot to talk about there. So we need a break just to get ready for that long haul. And then there'll be a wrap up, of course, questions if there's no questions at that point as well. So that's what's coming up. So the general introduction has got 2 parts. First, can't quite see it because my screen is blocking it. There we go. I want to talk about myself just a bit more than Lynn has, and then we'll get into the big climate picture. Whoops, that's a picture of my granddaughter. Here I am. So as Lynn has explained, I've been in the building industry for a long time. But I really got focused on residential buildings, particularly homes, when I took the passive house design class, which is an intensive class. I had to fly to Philadelphia to take the week-long intensive class and really get deeply indoctrinated into what we can do in our homes and actually in commercial buildings, because the same principles apply. So that's where my knowledge is based, although I've studied and done a lot of other things related to energy and buildings. I think I've got pretty good knowledge base, probably better than a very high percentage of the general population, but I'm still learning. And I don't know everything there is to know about energy efficiency in homes. And I may have to punt if you ask a question that I don't have an answer to, but I can probably help quite a bit if you stick with me here this evening. So let's talk about the big climate action picture. There's a lot to consider. And there are 5 big impacts that we all make that we need to keep in mind. And I want to emphasize the importance of collective action. And all this is important to keep in your memory when we're talking about a single house or your single residence. We've got these big human nature hurdles that we all have to overcome to fight climate change. We have a human nature tendency to focus on immediate threats, not long-term. We want simple answers, not complicated ones. We have trouble identifying misinformation. We have a clannish or tribal nature. And we first look out for our self-centered personal interests. And those are all challenges we have to work to overcome if we're going to fight this climate crisis that we're experiencing, that's certainly going to get worse if we don't fix a lot of things. And of course, I'm sure you all know about the urgency, but just in case you need reminding, we're really close to a tipping point in the climate warming scenario. And that is when the Earth itself takes over and keeps warming regardless of what we do. And we're really close to that now. And we know that because scientists are telling us that the poles are warming a lot faster than the rest of the planet, particularly the North Pole, where we've got not only a lot of polar ice that reflects sunlight, but we have a whole lot of permafrost and tundra, shown here in blue, that when they thaw, release a whole lot of CO2 and methane into the atmosphere. And if we get warm enough, that'll be a vicious cycle that we won't be able to stop. So one other thing is the climate change issue is a giant jigsaw puzzle. And there's nobody, including me or anyone else, that really can identify all of the pieces in that puzzle by themselves. And there are many people who know what parts of it look like, but not everyone knows the whole picture. It doesn't mean we should give up, though. We need to keep helping ourselves to learn about it and helping others to understand it. One last thing, there's no need for rocket science in solving the climate change problem. We really have all the technical skills we need. What is missing is the will to do it. And then I want to mention the 5 different big impacts that we have to keep in mind as we talk about just a part of them, that is our homes and our residences. Our biggest problem is our use of fossil fuels, and those materialize primarily in our buildings and in the transportation sector that we use. And of course, there is some fossil fuel consumption and involved in the production of goods that we consume. Another big factor, though, in climate change is the types of food we eat and in how we care for the land. Our soils are really potentially great sources of sequestration, even bigger than our forests. But when we put all the chemicals on them for agriculture and other reasons, we destroy those microbes that are sequestering. So we need to remember that and move other circles to address those problems as we do for forests and other natural habitats. And of course, water use and waste and landfill are other problems, but the big 3 are those in bold here. So lastly, in the introduction here, the importance of collective action. We talk about fixing our own homes, but your voice matters in our government attempts to fix the problems. And you really need to think about that, how you can contribute to our government actions for changing climate change. Because what we do as individuals in our own homes or our own lives is pretty minuscule when you compare to what we collectively do and what the government can help us to collectively do. Okay, so enough of the general introduction. Let's put the carbon impact of homes into perspective. First of all, this is a big pie chart with a picture in the middle that the Rocky Mountain Institute has put out in recent years, showing where our greenhouse gas emissions are largely coming from in our cities. This doesn't show where emissions are outside of our cities, but cities account for about 75% of our national greenhouse gas emissions. So this is important. And you notice that this pea green or yellow half circle is buildings, and the dark blue is the transportation sector. So buildings account for about half of our emissions problem, transportation for 35, maybe 40%, depending upon where you're at. And then there are other things like industry that have additional impacts. But I wanted you to see that the building sector has a big impact. And this little gray line inside of that building sector designates the part of the electrical grid and what that plays in our building emissions. The electrical grid is not yet clean in Washington State, except if you live in Seattle, where it is. And it's not green across the country yet. So that is part of the problem that will address the buildings issue. Just for example, here in Bellevue, where we have greenhouse gas emission inventories taken every year, 25% of Bellevue's community-wide greenhouse gas emissions are associated with residences. Another 25% is commercial buildings. And then there's the 34% for transportation impacts. So this holds true in Bellevue as well as nationally, um, like the photo or the graph I just showed you. This is kind of interesting nationally. Um, in rented buildings, electricity is doing most of the space heating, whereas in owned buildings, which are mostly single family, this pea green shows that gas is doing most of the heating of our space. So it's significant to notice the difference depending upon whether you're in a multifamily rented situation or you're in a single family home situation. So what kind of problems do we have in our home? Well, it relates to what kind of energy is being consumed there. And this again is a national average, but it's pretty typical. Notice that in a typical home in a residence, about 45% of the energy being consumed is related to space heating. There's another 9% or so relating to space heating. And of course, the size of these two parts of the pie change depending upon where you live. In Arizona, I think the size of these two wedges would be flipped. But this is probably fairly close to reality here in Northwest and the greater Western Washington area, and probably even Eastern Washington to some extent. But a big part of the pie is also water heating, on average 17%. So when you put all this space and water heating together, you've got a picture that approaches 75% of the energy consumption. And depending upon the fuel sources used for each of these different elements, that can account for a lot of our carbon footprint in our buildings. For example, if we're using natural gas to do our space heating and our water heating, there's 55, 60% almost of our energy consumption, and that is all greenhouse gas impact. So it's important how we are spending the energy in our buildings, and that's how it typically breaks down. So just an aside question that often comes up, why not just electrify everything? And I'm not opposed to that, but I just want people to be aware that our peak load on the electrical grid here in Western Washington, as well as Eastern Washington and other parts of the Northwest, occurs in the wintertime. Buildings are about 80% of the current electrical demand on the electric grid. So buildings play a big role. And if we move to electrify buildings even more, that's going to really drive up that peak demand on our electrical grid and make us have to pay for increasing our electrical grid infrastructure. And the question comes up of new buildings versus existing. Everybody immediately starts to think, well, we better fix our building codes in new buildings. But the reality is our building codes are tightening every 3 years by a law that I helped get passed back in 2007. So we're seeing new buildings have less and less impact on the electrical grid and on our greenhouse gas emissions. Not that they are important, but compared to the existing buildings, they're a much, much smaller part of the problem that we have to solve. And the question gets here that I raised, who pays for that electric grid infrastructure if we have to expand it? Well, we all do, all of us that are paying for an electric bill. And lastly, the Federal Department of Energy and many others have recognized that on average, there's a huge energy savings opportunity in our existing buildings, not only commercial, but also residential buildings. It's estimated that about half of the energy that our buildings use is wasted. And hopefully with the right measures, we could save a good part of that. And then a question that comes up to mind when we start looking at the price tag of all the things that we might do to our existing buildings, well, why not just tear them down and build a new one? Well, in some cases that might make good cost sense, and I'm not opposed to that necessarily, but we should keep in mind that whenever you build a new building, we're using resources. And if it's wood, we're cutting down trees. If it's steel, we're causing a lot of emissions with the steel production, the same with concrete. So if we can save our existing buildings and reduce their carbon footprint, it makes a lot of ecological sense. So all that said, let's talk about some easy first steps that homeowners can take. These are common sense that I'll bet most of you and maybe even all of you know, but let's review them real quick. We need to replace those old incandescent bulbs with LED bulbs. No matter how old those incandescent bulbs are or how new they are, an LED bulb will pay for itself in 2 years or less. So most likely a year in most cases. So switch out and get rid of all those old incandescent bulbs if you still have a few around. And most of our buildings, most of our homes leak a whole lot in terms of air passing through the walls and the openings that we give them. So we really need to be sealing those exterior leaks and weather strip around existing doors to the best of our ability. And then we need to caulk and seal around all wall penetrations. That's around windows, that's around pipes and electrical fixtures that might penetrate through a wall. If you've got a light outside of your home, there's a penetration through the wall getting to that light. And you want to make sure that that's sealed well. And the same is true for any plumbing, like a hose bib that's on the outside of the home. Indoors, we should use motion sensors on switches in rooms where people are in and out of a lot, so that we don't have to leave the light on all the time. We should install water conserving faucet heads and shower heads on all of our plumbing fixtures. Outside, we should use drop-friendly plants and drip irrigation in the yard. And we should talk up smart conservation with our family and other people who share our residence. So here's a list of family conservation topics that should be talked about. I'll run through them really, really fast. Turn off the lights in unoccupied spaces. Turn off radios, TVs, and computers and appliances when not in use. Minimizing the opening of refrigerator and freezer doors. Minimize hot water use. Use cold whenever possible. Set that hot water temperature low. Dry clothes on clotheslines or drying racks rather than in a dryer if you can. Run only full loads in the dishwasher, clothes washer, and dryer. Cook more with microwave rather than a conventional oven. Keep the windows closed tightly when fresh air isn't needed, and don't leave water running. All common sense things you all know, but it doesn't hurt to remind yourselves and go over it with other people in your family. So what you probably came to hear about is the long-term improvements and what we need to be doing. But let's just briefly talk about why to make a long-term plan, because that's the next most important thing to do after looking at easy conservation measures. Need to think long-term to identify future obsolescence opportunities. Someday your roof is going to need to be replaced. Your furnace your water heater, and many of your other appliances. So stop and think about that and plan for it. You need to know how long your roof's going to last, your furnace and so forth. So figure that out, put it down on a calendar and schedule that in reality, both in your time schedule, but also in your budget. And then consider nice to have improvements. And we're going to go through a few of those today that you might want to also add to that schedule and add that to your budget. And then figure out how to bundle some of those improvements into phases. When you put on a new roof, somebody had a question? Okay. When you put on a new roof, that gives you other opportunities to consider. And we'll be seeing some of those as we go down through the long range options that you might face. So sitting down and making a long-term plan for what is obviously necessarily coming up and what you might like to have is really important for you to reduce your carbon footprint over time. It can't all happen overnight unless you're extraordinarily wealthy and willing to endure one heck of a lot of disruption in your home. Now, I think covered all of these elements except the last one. When you're doing many of these things, there will be disruption in your home. And that's another reason to consider how you're going to phase these improvements and how much can you and your family tolerate doing all at once. It can be very, very disruptive. So let's take a few minutes break here. I think if you've got questions, please put them in the chat. And I'm going to take a couple of minutes to run down the hall and get myself a little bit of water to drink. And you might do the same while you're putting your questions in the chat. I'll be right back. So Lynn, what kind of questions do we have? You're muted, Lynn.
People are asking about things we had advertised you would talk about. So they want to know about heat pumps and they want to know about windows and how you make the decisions about windows. And
they're coming.
Okay. Oh, when replacing water heater, how to overcome the installer bias towards gas. Yeah. So those are the questions we have so far.
Okay. Yeah, I hope I
Oh,
didn't bore you to death with my overview and approach here, but yeah, I'm getting into all those details next.
oh, someone did ask, because you'd already said this, you had said microwaves were better than conventional ovens energy-wise, and they wanted to know why.
Um, Basically, resistance coils of a conventional oven consume a lot more energy than the microwave heating process. So we'll leave it at that and get to the good stuff people are looking forward to. So let's talk about specific long-term options. And the first of these areas of discussion is focusing on space conditioning and carbon impacts for space conditioning. Um, there are two aspects of this. One of them is reducing the exterior heat loss or gain through the building envelope, the walls and the roof and the floor. And the other is converting from gas heating, if you have gas, to heat pump technology. And actually, if you have resistance heating, baseboard heating, that's very energy intensive, and conversion to a heat pump will save you a lot of energy as well. So we're going to talk about both of these, but we'll talk about them separately. So we'll be talking about the exterior envelope heat flow or weatherization first. And that's where we get into windows and lots of things. So weatherization is going to break down to these 7 categories. I want to talk about a little bit about heat loss and then detecting heat loss, thermal conductance, vapor barriers, insulation, air leakage, and windows. So heat loss background. We lose heat, or heat's transmitted in our buildings and homes in several different ways. First of all, there's thermal conductance through rigid materials. If you've got a material like an aluminum window frame that is totally connected through metal from the inside wall to the outside wall, there is heat traveling through that window frame in the direction of the cool side. Another way of heat being transmitted through our walls or ceilings or whatever is radiant heat from a heat source. And I think you all understand that. Also, you all understand how air leakage allows heat to pass through cracks and gaps. And something you may not think of right away is there's circular air currents or convection currents moving on wall surfaces and even inside empty wall spaces. And those convection currents moving air cause heat to be transmitted through the wall from the cold, from the hot side to the cold side of the wall. And finally, we all know that sunlight beaming in through windows is another way for heat to come into our homes. And we get worried about that, especially in the summertime. So those are some basic ways that heat gets lost or transmitted through our walls and ceilings and so forth. So we can detect that most easily using infrared imagery. And you can hire a consultant to do this, or you can go try to do it yourself and purchase a infrared camera like the one pictured here. I do recommend that you hire a consultant to do it. They typically are not very expensive, and you might spend a couple $100s on having them do this, but they know how to interpret the the imagery probably better than you can do yourself. But here's an example. The red is the rapid transmission of heat or heat loss. And notice that it's around the window frames. These are probably aluminum windows. And here's an example where there's significant heat transmission occurring where a balcony penetrates through a wall. And that's probably because that balcony is a concrete structure and it passes all the way through the wall so that there's conductance going right through that that wall through the concrete. And then the other colors, the green is probably showing some air leakage around the openings. Thermal conductance happens in our window frames, and we really need in a metal window frame to have what's called a thermal break, which is shown here in green, so that there is no direct route through the frame from the inside to the outside. No direct metal route, so that the conductance in the metal is interrupted. And most of your new modern metal window frames have that feature, but most of our existing metal frames that go back a few years don't. So it's a reason to consider replacing your windows just because the frame may be transmitting a lot of heat through the wall. Vapor barriers are another thing that we need to be thinking about in our walls. If you've had mold problems in your exterior walls, it's probably because A, you don't have insulation in the walls, and B, you probably don't have a vapor barrier to avoid or prevent the air vapor, which has moisture in it, from going through the wall and carrying that moisture into a point where it condenses and becomes water and feeds mold growth. In new construction, we typically put on vapor barrier sheets, but in existing buildings, unless you're going to totally tear apart the wall structure, one option is to get a paint that you might need 2 coats that has that feature of offering a vapor barrier. Insulation is a big opportunity to save energy and reduce your carbon footprint that way. And in a airspace, filling an airspace tightly, it blocks those convection currents that transfer heat through a wall. So insulation is really important. There are different forms. You've probably all seen bat insulation, which can be either rock wool or sometimes called mineral wool, which is ecologically quite friendly. And then there's the fiberglass option that's a little less expensive, but not quite so eco-friendly in its manufacturing. And then there are rigid board forms of insulation. Rock wool comes in a rigid board. We used it in our house. And then there's polystyrene, polyurethane, and perhaps some other rigid plastic oriented boards that are often used in improving insulation or in new homes. Another option is to have blown insulation blown into an empty wall cavity or into an attic. And I think cellulose is probably the best option there. It's ecologically friendly, and unless you know someone that can blow in rock wool, I would stick with cellulose to blow into empty wall cavities. Foam is another option that some people can do, but I'm not really familiar with those products. And I don't want to be familiar because from what I know, they all have ecological and human health concerns associated with them. So without taking a wall apart, if you've got no insulation in the walls, blowing in insulation is, or in the attic, is a good solution. And where you can add insulation to an exposed surface, like maybe in a crawl space or in an attic, a batt insulation or even rigid board might be a good application. FYI, the current code requires R21 in exterior walls and R36 in our roofs. So you can get there if you've got enough space. But if you've got, for example, a 2x4 wall in your existing building, about the best you can do is an R7 batt insulation or blown insulation in the wall. And to get beyond that, you need to think about either tearing out your interior wall finish and furring into the home and putting in more insulation that way, or do the opposite on the outside, tear off your exterior wall covering, your siding, and frame out more and put in more insulation on the outside. But that can get expensive and you may not want to go that far. But many of our homes, particularly those built before roughly 1970, have very little, if any, insulation in the walls or in the attic. So adding insulation is probably a good and not very expensive solution to an existing building of that age. Air leakage is a real common issue in most buildings. In new construction, we add an exterior weather barrier. Probably seen new homes under construction and even commercial buildings. And the most common product for a weather barrier out there is called Tyvek, but there are other brands that work just as well. But that's what's going on. They're put on the exterior of a home to reduce air leakage. And when you've got plywood sheets going up on the outside of your home, they've got likely gaps at the junctions and intersections. And that's where air can penetrate through the walls. So that's what Tyvek is used for. Related to that, incidentally, typically we see in new construction rain screens added that allow, outside of the Tyvek, allow water to drain through if it leaks through the siding or some other part of the building enclosure. There's just a pathway given for water to drain out so that it doesn't build up in an envelope. And it's also, they have a window framing wrap that works at keeping the moisture away from the framing of the home around the windows. And finally, we need to be filling up the gaps around our windows and other openings with either insulation that we stuff in or foams or caulking. And finally, windows here. There's a lot to talk about windows, and put your questions in the chat if I don't cover them. But there are a number of factors to consider. The number of glass panes that you have in your windows is important. There was a time when people were saying, oh, you don't need triple pane around here, but I recommend it, and the architects that I talk to recommend it. So if you're going to replace windows, think about doing triple pane. If you've got a good, less expensive option on double pane, windows, make sure they've got good reflective coatings on them, and how those coatings are applied will affect their ability to protect you from conductance and transfer of heat. And the gas that's used in the spaces between window panes, the best is argon. Some window manufacturers only use air, but most are now using argon, and that has less density than air, so it's a little better product for cutting down heat transmission. And I already mentioned the surface coatings on your glass are important. The sun orientation of a particular wall where you're putting in windows should be taken into account. If you're on a side of a house that's exposed to a lot of sun and doesn't have any shading, you want to make sure that you've got new glass in the windows that are very reflective to UV and sunlight. And finally, you want to look, not finally, but next you want to also carefully consider the window frame material. If it's metal, does it have thermal breaks? Make sure it does, so you don't have that conductance problem and the sweating that results from conductance through a metal window frame. Wood window frames are good if they're well sealed. Fiberglass is a great framing material for windows. Vinyl in today's market, there are pretty good vinyls out there. Go back 10 years or 20 for sure. The vinyl windows of that era were really subject to ultraviolet degradation and didn't last very long, but most of the newer windows from reputable manufacturers have pretty good ultraviolet resistance. So they're not a bad investment, at least if you are wanting them to last 20 to 30 years. And then finally, there's aluminum, but again, make sure you've got metal brakes. They'll last forever, but if you don't have thermal brakes, they're going to be a problem, and you don't want that. A couple other things to keep in mind. When the windows are installed in an existing building or even in a new, they work best at limiting heat transmission if the glass in the window is in line with the insulation in the wall. A lot of our replacement windows and even new windows come with fins around the edge, extra lips on them. And that means that they are sitting on the very exterior face of the wall assembly. And my architect recommends, and I've seen data suggest that's not a good idea. And in my case, where we had fins come with our new windows, we cut the fins off, and that allowed us to set the windows farther back into the wall in line with the insulation. Preparing the window opening and setting those windows is really, really critical to avoid air leaks, water leaks, and potential mold problems. So I really strongly advise that you get an architect to design the window frame outline of a window when you're doing the replacement, because you need protection at the head of the window to divert water coming off the face of your home down your siding, for example, to divert it away from the window. And then you need at the sill, you need to make sure there's a design so that the window is sitting in the wall assembly, and at the base of the window, at the sill, there's a sloping member in the wood framing that in the case of any moisture getting in to the window assembly, it's going to come down to the bottom at the sill. And if the sill is angled, it will flow out and away from the wall. So little tricks like that are not normally known by a lot of our builders. And you want to make sure they get installed right if you are replacing windows. And then as I'm pointing out in the last point on this slide, the skill of the installer is critical. You need a tight fit, and you need a proper weather wrap around the window opening before the window gets set. And that window wrap must be properly tied into your weather barrier like Tyvek. And then the gaps around the window frame need to be sealed properly. So here's just a quick look at what the head flashing that you need at the head of a window looks like. This upper piece sticks up under that weather barrier. And so water's going to come down the face of the weather barrier and hit this metal and go off out beyond the wall, beyond the window, and flow off of the drip edge. Here's the kind of detail we need to see in preparing a window opening before the window gets set. It's really, really important that we get this kind of weatherproof, waterproof membrane attached to the window opening. First, the sill gets wrapped, then the sides get wrapped, and then the head gets wrapped so that there's a constant barrier for air and moisture penetrating into the wood frame of the building. And all of that gets tied into the Tyvek or the weather barrier, which goes over this and gets taped to it when that weather barrier is installed. So here I'm just, this is expensive, so many of you are not probably going to want to do this, but this is an example of what we did at our home. And the steps are apparent there in the photograph on the left. What you don't see is we teared off all the old siding. Our home was built back in the mid-50s. So that was before there was any seismic and earthquake preparation considered in construction. So for our seismic stability improvement, while we had the siding torn off, we added plywood sheeting that wasn't there. We had just an old fiberboard, which doesn't have any rigidity to it, and it's not seismically helpful. But then over that plywood, and we sealed all the plywood joints first with a liquid compound that seals the joints. But then we put the Tyvek over that. Notice there's at the bottom of the single story wall here with blue tape on it, marking where the studs are behind it. But the blue tape comes off. This is a metal flashing at the bottom. So any water that comes down the wall behind the siding or around the windows when the assembly is all done, any water that comes down the space in the wall hits that, pardon me, go back, hits the metal drip, and that directs the water away from the house and away from the wall. But after the Tyvek goes on and the windows are set, then the design called for furring strips. That's these dark brown strips, which are wood that the siding gets attached to as the siding goes on. And between those furring strips is rock wool board that adds insulation thickness to our wall. We, of course, added a whole lot of insulation as we were able in the 2x4 original house framing. So this is what it looked like going together. And we had visqueen over the roof edge to keep it dry during the weather that occurred when it was being done. And here's what the nearly finished exterior looked like with new siding. This is lightweight, hardy cement board siding that is very rot resistant and light because of its composition. And when it's furred out, we want something light that doesn't need a lot of support nailing into those furring strips. But you see all of our windows have extra framing around them too. And you can't see it unless you get up close, but this sill piece under the window is sloping outside like I talked about, so that any water that does happen to penetrate around the window installation will come down and be directed out away from the wall. So there you have all the gory details of the big exterior improvements we did. We also put on, in a different phase, a new metal roof. And when we did that, we added plywood sheeting to the roof structure. And we added a couple layers of rock wool board insulation. We also blew insulation into the attic. So we put a whole lot of insulation up above. Then we put a new ice shield membrane, it's called, over the second layer of plywood. And then we added a metal roof and we added metal gutters here, which you can see in the picture. So there's all you ever want to know, probably more than you ever want to know, about weatherization and exterior envelope improvements. Now let's talk about heat pumps. We're an hour in to this program, and Lynn told me we might stretch to an hour and a half. The heat pumps will go fairly fast, but we'll be getting close to questions here pretty soon. So I want to talk about how heat pumps work. I want to talk about two types. There are air source heat pumps, and there are two types of those, ducted and ductless systems. And then there are ground source heat pumps as well. So we'll talk about all those. You already have a heat pump of sorts in your home if you've got a refrigerator or freezer. The principle is the same for airspace heating or cooling. And I'm not going to get into the details in real detail of how these work, but it's much like a refrigerator. There's an outside coil and an inside coil, and fans that blow across both coils, and circulating between them is a refrigerant line, which transfers itself from a liquid state into a gas state. And as it does that, it releases heat. So that's how these in principle work in transferring heat from one side of a wall to another, or one side of the refrigerator to another. In a ducted air source heat pump system, you've got two components. It's sometimes called a split system. You've got an interior unit. This is the unit in our garage that's sitting on the pedestal where our gas furnace once sat. And this is the outside unit that's got the outside coil in it. And you can see right here, there are refrigeration lines connecting the two. They're on the inside and they go up in our garage and come out on the outside wall here. And the black, the refrigerant line is the white one. The black line is the electrical line connecting the two. And this is the electrical outlet that we had put on the outside also that related to that installation. The ductless heat pump systems are used in existing buildings and homes that don't have ducts already existing. So if you've got an electric baseboard heating system in your home, for example, to save energy and thereby reduce your carbon footprint, you might want to consider a ductless heat pump system. Or if a part of your home is particularly uncomfortable, like maybe an attic room, you could have a ductless heat pump system installed that would just address the heating or cooling of that one room. And on the interior, you get this kind of protrusion into the wall that is your interior coil, and air is blown off of that to heat your room, or when you reverse it, to cool a room. That's one of the advantages of having a heat pump system is they can be reversed so that you can heat in the winter and cool in the summertime. And as our summers tend to be getting hotter and hotter, that's an important feature for a lot of people. So just to review, a ductless heat pump system has two components, an exterior fan coil unit and an interior, and they're connected by probably electrical lines as well as refrigeration lines. And most of these come with a remote control like this lady has demonstrated, so that you can adjust the temperature and the fan speed on your interior side. So another kind of heat pump system for space heating is called a ground source heat pump. And the principle for refrigeration and heat exchanges is very similar, but the heat is pulled from the ground below the home, and pipes have to be drilled down into the ground, and not all soils will accommodate those well, but most in our area will. So you have to have somebody study your soil before you even consider this. But the nice thing about a ground source heat pump system over an air source heat system, is that the ground temperature is pretty much the same year round. Once you get down about 3 feet, it's about 52, 53 degrees. And so these are very efficient on the heat extreme days when it's very hot outside or when it's very cold outside. And you don't have to worry about your heat pump ever freezing up, because it's only circulating water at a temperature of 52, 53 degrees. And though this is old technology, it's pretty expensive, or at least it's more expensive than an air source heat pump system. But that doesn't keep people from wanting it. I've got a good friend who installed one several years ago in his home. And just this past year, a neighbor down the street from me had one installed, and they drilled the circulating water lines right in their driveway, which I was surprised to see. And it's now operational, and from all I know, working just fine. But it does have a higher installation cost at the outset compared to the air source heat pumps.
Court, I'm just going to throw in one question right now that somebody
Sure.
asked. They said, I've heard that ducted heat pump will only heat down to an ambient outside temperature of 45 degrees. True or not?
That was true about 20 or 30 years ago, but our technology's improved quite a bit. Most of in fact, probably all of available heat pumps today are good down well into the teens. And if you get a certain kind of booster feature, they can go below that, below zero. And they're being air source heat pumps are being promoted in states like the New England states and Maine, because they work at all winter temperatures now. If you get the right heat pumps, then they're widely available. So that's old news and continuing misinformation, actually, that some people who want to promote keeping our gas furnaces may be circulating. So happy to take more questions now if you want to, but I've got a few other things to go through.
Well, I've got some ones that are just about heat pumps, so maybe we should take those right now.
Yeah, let's do that.
Okay, one question, how old might a 95% efficient gas furnace be for it to make sense to replace it with a heat pump?
I'm not an expert there, but my experience is if you get one to last 15 years, you're on the unusual side of lifetime. I'd be seriously contemplating replacement before it dies on you if they're 12 or more years old. But that's just my personal judgment. I'm not an expert on that. However, I do want to add, if you are contemplating doing a heat pump, you want to make sure that you plan it and execute it before your old furnace, gas furnace dies, because the installation process is not instantaneous. They have to order the equipment, schedule the crew, and get it done in a time frame of, dependent upon the installer, a month to 2 or 3 months. And you need to make sure you do that planning well in advance of the expiration of your gas furnace.
Yeah, and after the heat dome, they were backed up for months and months and months of people trying to get in.
Yeah, I put my order for my heat pump system in last May, and it was back ordered, and it's not an unusual system, but availability was being difficult, and I didn't actually get it in hand until the end of August, and I wasn't able to schedule the installation until October. That's how backed up the contractor was that I contracted with. So
yeah,
you need to think several months in advance for making the switch to a heat pump from a gas system.
Yeah, I would even add, if you're determined that your next heating source is going to be a heat pump, don't think, well, I'll wait to the end of the life of the thing. Like, you're going to have to do it before it dies. Okay,
Yeah.
Here's another question. Are heat-only heat pumps available? We don't require air conditioning, just heat. It would certainly make for a simpler design and maybe then a cost reduction question.
I don't know the answer to that one. I doubt that they're even available. And if they are, I doubt that the cost differential is significant. But I really don't know, so I'm speculating.
Okay. Those of you who are curious about this might want to look in the chat. Paul Christensen put in a YouTube link that shows exactly how a heat pump works for people who are curious about that. The next question about heat pumps says, we have a gas water heater that also runs our in-floor heating. Is it possible to replace this with a heat pump? If not, does it make sense to replace with electric hot water heater?
I don't specifically know the answer, but I'll bet there is a specialized hot water system available that's a heat pump. Another option is to replace your hot water heater with a heat pump hot water heater and go to a ductless heat pump system and abandon your circulating hot water system, which is probably in your floor. So those would be things to consider, but you need to talk to somebody. And there aren't many folks I know that are experienced with that. But a friend of mine has had that problem with his home and is headed that direction.
Okay, here's another one. It's a sort of a comment from your friend Catherine. She says, when you talk about heat pumps for furnaces, could you distinguish between heat pumps being used on natural gas furnaces versus heat pumps being used on electric furnaces? Some people think that just getting a heat pump furnace is all they need to do, but the furnace industry keeps pushing natural gas furnaces and adding a heat pump. People then think that they've done the heat pump thing, not realizing that the better option is an electric furnace with a heat pump.
Yeah, and that's part of the old school throwback to when electric heat pumps were only good down to freezing or just above freezing. So the gas utilities and gas furnace manufacturers were coming up with these options that they were pushing. But that's old news. And as Catherine points out, you can do the whole thing with a with an electric heat pump system, not needing any gas support at all.
So that relates to the next question, which says, when replacing water heater home heating systems, how to overcome the installer bias towards gas? They argue that gas is way less expensive.
Yeah, it's hard to change people's minds, particularly if they've got money invested and habitually used to doing things a certain way. So, and of course, our gas companies that are selling gas are always pushing any way they can to keep us using gas appliances and gas hot water heaters and gas furnaces. So you just have to search for the right company that knows how to do these things and is up to date and already experiencing how to put in a heat pump system. And they're getting to be more and more of those folks out there. And as was the case during our pandemic disruption of supply chains, all of them were having trouble getting equipment. But I haven't tested that water in almost a year now, but I've heard, and I hope it's true, that the supply chains are loosening up and that's less of a problem today.
Okay, I'm getting some people saying they want to hear the other parts of your presentation, so I'm going to let us go on now.
Okay, so if you're putting in a heat pump system and doing some other electrical related changes in your home, you're going to want to look at what your capacity is in your electrical panel. So in our case, we had to upsize our electrical panel, and most people who are putting in heat pumps are likely to have that need as well. So don't be scheduling a new heat pump installation until you've checked out your electrical panel and making sure that it has the capacity to handle the extra electrical load.
Which is a good time to put in an EV charger for your coming EV car.
Yeah, and a battery if you wish, and put in an electric heat pump water heater like this one here in our garage, where our right next to our plug-in hybrid is sitting. These electric heat pump water heaters are more efficient than traditional water heaters in terms of energy use, even less than a gas water heater. They do require an electrical hookup and a plumbing hookup. They are available in different sizes and shapes, and gallons of water that they heat. They use the heat in the air in the room where they sit, unless you happen to duct a connection from them through an outside wall. They're going to pull heat out of the room that they're sitting in. So if your existing hot water heater is inside your house somewhere, it's going to pull heat out of your house. In our case, it's in our garage, and we don't heat our garage, so we don't worry about the slightly lower temperature in the garage. And
Someone's asking you about that. They're saying, doesn't the garage get really cold in the winter? And how's that impacting the water heater then?
No, it's not very noticeable. I can't say as I noticed the difference, and the car doesn't care. So our wall between the garage and our living space is well insulated, so we don't worry too much about it. You do have to have a condensate line hooked up to this type of hot water heater. So that's one thing to be aware of. You might have to have a small pump attached to it to evacuate that condensate discharge to where you want it, in a drain, to a drain, or through a wall. In our case, we just ran the condensate line through the garage wall to the outside. They cost a little bit more than traditional hot water heaters, but some people claim I can't identify how much difference ours is than our previous gas hot water heater, because we didn't have the gas hot water heater separately metered. But some people claim that these are less cost to run than even a gas hot water heater is. So operational costs are less, even though the initial cost is higher. I can't personally verify that, but I've heard a few different claims to that effect.
And this is I just want to add, this is another case where right when your water heater breaks is not the time to be trying to figure this out. You need to have figured it out ahead of time.
That's right.
I also have a question to you, Court, from someone saying, can you comment on on-demand water heating systems?
Yeah, I've had that question before, so thanks for bringing it up. On-demand hot water systems just do a quick heat of the water when you turn on the hot water. They're not very energy efficient, though you get immediately hot water at the tap. The option is exactly what I've got up here on the screen right now. For a few $100s, you can go buy a hot water circulation pump that you can put in typically under a sink, and you run it through the water feed lines that are feeding your faucet at your sink, and you have to have an electrical hookup with it. But the beauty of these things is, when you want to be sure you're going to be using hot water, you either time that on a timer so it automatically circulates at that time, or you go switch it on so that you've got hot water circulating through your hot water pipes. And when you turn the faucet on or the shower on, it comes out hot right away, and you don't waste water, and you don't waste the energy of heating the water that otherwise goes down the drain as your shower water's warming up. So that's the more economical and ecologically sound solution to wanting to have instant hot water at the tap. Another option for cutting your carbon footprint is to go to induction stovetops, such as the one pictured here, which we really like. It is fast heating, actually a little faster than heating with gas. There are no toxic fumes, so it's better for your health. The fumes from an indoor gas range or gas stovetop are hazardous to your health. And so this is a health concern as well as an energy concern and a greenhouse gas concern. These are very easy to clean. They're just a glass top. And they're the large combined units like shown here requires a 240 volt outlet hookup. So that's another reason to make sure your electric panel can handle it. And there are other models besides this combined electric range. You can get, excuse me, you can get a built-in countertop unit that's just the stove top. And there are also very small units that are like hot plates that'll sit on your counter if you're in a rental unit and still want to use that induction stove option. Sort of like a microwave. They're very low energy consuming, and they heat things up really fast. So highly recommend it. There are other electrical appliances that are energy efficient that you should be looking into. If you've got old appliances that are more than, I'd say 10 years old, they're probably due for replacement soon. And there are likely newer models out there that have better Energy Star ratings by the federal government that use a lot, are much more energy conserving. So make sure you look for the Energy Star ratings on any new appliances. And also keep in mind.
Kurt, can I just mention one thing about the refrigerators?
Sure.
We have just nationally gone to getting rid of one of the worst climate pollutants, which has been in our refrigerators. The ones coming out this year and after don't have it in it. So that's another thing if you're thinking about, what should I replace, my refrigerator, my clothes dryer, my dishwasher, whatever. Just be aware that the refrigerators have been able to leak a very potent greenhouse gas.
Yeah, and there's a similar problem with heat pump systems. And if their refrigeration material leaks, that's a big greenhouse gas problem. So you want to make sure you've got a heat pump installer that this is for airspace heating. It's not true for the hot water heaters because that's all self-contained in the hot water heater from the manufacturer. But you want to make sure you get a good installer that tests those refrigeration lines out very carefully before they put the refrigerant in those lines. And most of the models in recent years have not the best refrigerants as far as greenhouse gas emissions are concerned. They're moving towards using carbon dioxide as the refrigerant in future models. So those will be coming out with better refrigerants, I'm told, in the not too distant future. Let's move along. We're getting close to the end. There are real advantages in shading your home, which everybody knows, but sometimes don't think about. If you're worried about those days in the summer, they're getting warmer. you might want to plant some trees, and they help to keep the home cool in the summer. But when the leaves fall off, if they're deciduous trees, they allow the sun to warm the home in the wintertime. So they're great on the south and west sides of a house. A brief comment on chimneys and fireplaces. We had a fireplace in our living room and a chimney through the middle of the roof. And the flashings on the chimney leak from time to time. Of course, it's a 50 some year old home. The brick mortar, pardon me, the brick mortar was starting to fail and need touching up. And in any case, a fireplace and chimney are a constant draft and heat loss vehicle. Even when you've got a damper, most of those dampers don't seal well. And there's a conductance problem all the way up the brick and mortar that's losing heat that goes through the attic and the roof. So we just totally took ours out when we put a new roof on, and we weren't using the fireplace much anyway. So you might think about doing that if and when you're going to put on a new roof.
You have a related question to this one. It says, what about gas fireplaces? What is the effect of an open flue when the gas fireplace is not in use?
Very similar. You've still got a chimney, and it's a significant heat loss. A regular wood fireplace doesn't typically allow much heating going into the home, and it mostly goes up the chimney. Gas fireplaces are a little better, but again, they're gas. That's greenhouse gas. And if you're worried about your carbon footprint, yeah, that may be something you don't want to have in your home. When you replace your roof, one of the things to think about is if you ever might want to have solar panels on your roof, putting on a standing seam roof like the one pictured here is a good way to go, because the frames to support a solar panel or assembly of solar panels can clamp right to the standing seams and thereby not penetrate the roof membrane, as is required for nearly every other kind of solar panel framing installation. Those frames in a shingle roof are supported by pedestals that have to penetrate all the way through the membrane typically. And so if you're gonna replace your roof, think about putting on a standing seam metal roof. And of course, you want a metal roof or any other roof that's highly reflective if you're concerned about warming the planet and our libido, I think is the word, our Earth's reflectance of sunlight. So make sure you use a color in your roof, your new roof, that's highly reflective.
A roof question. If you put on a metal roof, how noisy is it really when it rains?
Well, we've got one, and I hear a very heavy rain on the roof, but I heard a very heavy rain on the roof with the previous build-up roof that we had. So I'm not irritated, and the noise doesn't really bother me. That most often we just have a light rain and we don't even hear it. So you only really notice it in a very heavy rainstorm, and those are really pretty short lived around here. So I don't think it's a big issue myself. So if you've got a standing seam roof, you're able to easily put on solar panels, and not a bad idea. They do cut down on your electric bills and they pay for themselves. So, and they pay them for themselves before they're old and have to be retired. So it's not a bad investment. The thing you want to be aware of is they don't produce much output in the winter months. Oh, and also you got to make sure your roof isn't shaded or they won't be very effective at all. But even if the roof isn't shaded in the winter months, there's very little production because the sun is so low on the horizon for our latitude. If you live in California, they're even great in the wintertime. And that's why there are a lot of sales in California. But up here at our northern latitude, they don't help us much in the coldest winter months. And that's when we have the peak load in our electric grid. And that's what we need to be mindful of as we go electrify our buildings and our homes. We need to keep as much as we can the peak load down in the wintertime so that we don't have to build a lot of new electric grid infrastructure. So that's the only downside is they don't help us much in the wintertime. But of course they do help in the summertime and in the shoulder months of spring and fall. So just two more things.
Wait,
Batteries.
before you go to batteries, could you
Okay.
just say, like, people are aware that solar panels used to cost a lot. And could you just talk about the price coming down on them?
Well, they've come down a lot. They're a lot less expensive than they were even just a couple of years ago. Well, I take that back. There's been an upsurge during the pandemic because of availability problems and because there was a heavy tariff put on panels coming out of China where a lot of them are produced, but not all. So price I've heard has been fairly stable in recent months, and they're much less expensive than they were 5 or 10 years ago. And even our electric utilities now realize that they're one of the cheaper forms of electrical generation for them to use on the whole grid. Again, the problem is at our latitude, they can't count on them much in the winter months when they have their peak load.
Thank you.
Okay. Couple more slides here. You've all probably heard about batteries in the home. They're great for when you have outages, but most of these battery systems are fairly short on their range of output. Though you can certainly buy many of them and build that up, but that gets to be expensive. It will become likely more beneficial to have one if and when our utility companies start to charge different rates for the different hours of electricity use. That is done widely in California already and some other states, but hasn't been done much here in the state of Washington yet. I do believe that is coming in PSE, for example, Puget Sound Energy has said that they are evaluating that and considering that. And I wouldn't be surprised if other utilities, including Seattle City Light, is also considering that. When they go to that, the electrical grid usage, of course, varies with the time of day. The peaks are typically at breakfast time and at dinner time. And so if we could have the ability to switch off our usage from the grid at those times and use our battery power, we probably would save some money. The economics are yet to be determined, however, because we don't know those future rates of electricity at different times of the day. So we can't do the math to see how cost effective battery investment would be, but something to consider in the future. And I have some friends who have solar panels on their roof, and the batteries to store that surplus energy on the middle of the summer days, especially, that will carry them through the night and really make a cost-effective package for most of the year when the solar panels are producing well. Something to think about. And lastly, but I don't think least important, is energy recovery ventilation system. We put one in our home, and for a couple of reasons that I'll get to, but how these work is they are typically an added ducting system in your home, often in the attic as pictured here, but sometimes in a crawl space if you have a crawl space and no attic. And what they do is you can see air coming in at one outlet, and it doesn't have to be in the roof, it could be in the wall as it is in our home. Air coming into the system and going in a duct to this unit that sits in the attic that heats that air up in the wintertime through a heat exchanger that's also pulling air out of the home and exhausting it through another side of that energy recover ventilation unit. So it's bringing in fresh air and piping it to all the rooms in your home that you pipe it to, and it's pulling air out of the home and exhausting it, going through a heat exchanger and using that air in the home to warm up the air from outside in the wintertime. And it works the opposite in the summertime. It'll use the cool air in the home as it exhausts to cool down the hot air it's pulling in from the outside. Doesn't use very much energy, but it keeps fresh air coming into the home. And that's a good thing for health and comfort. And if you put a MERV 13 filter on those, it'll filter out the smoke when we get those smoky forest fire sessions, and allow us to bring fresh air into the home that's not all smoky. So I think I just went through all those advantages. And I wonder if there are any last questions for those still with us.
Before we go to, there's quite a number of questions still in the chat, but before we go to that, we had advertised that you would say something about how people can prioritize. So if you have a home that, just really isn't energy efficient, it was built in traditional ways, it has all kinds of, not good things in it. How do you start to decide what to do first if you're not going to just do like a whole remodel?
Well, I had a slide that I went through pretty fast on that. First of all, you have to plan for and decide on what must be replaced. Certain things like your roof must be replaced, so you need to make sure you can afford those and schedule when those happen. Then you need to figure out what you'd like to do and figure out how your budget can accommodate those things. And then you need to phase them and package them in a way that minimizes your disruptions in your home. So you weigh your necessary investments with your nice to have investments, and then you package them at opportune times. Like when you do the roof, you also might want to take out your chimney, and you might think about adding solar panels. So anyway.
Is there anything that you see as biggest bang for the buck?
Well, the biggest bang for the buck is in this category in cutting the space conditioning carbon impacts. And that means doing what you can afford to do in your exterior envelope improvements so that you're reducing the heat loss in the wintertime or the heat gain in the summertime in that exterior building envelope, and converting to heat pump technology, especially if you've got a gas furnace. A lot of people are pushing heat pump technology and replacing your gas furnace as a high priority. And I don't necessarily disagree with that, but if your home is a big energy hog and has a lot of heat transmission through your building envelope, you might want to consider doing some improvements there first, because then you can probably downsize the heat pump installation and save some money. So it's a balancing act. It has a lot to do with your budget and the timing of retirement of existing equipment in your home, and your ability to tolerate disruption. But you're certainly, for example, going to want to do a heat pump change sometime other than in the winter, because you're going to be down and without heat for probably a couple of days when that happens at a minimum.
Okay,
So there are lots of things to keep in mind.
great. I'm going to run through some of these other questions that are in the chat. It says, you mentioned CO2 as a refrigerant. I've
Right.
only heard of it used for cars, which makes sense because they crash a lot and the refrigerants then spew out. Any thoughts? Is CO2 coming for homes too?
Yeah, that's what I was saying. I've heard that the refrigerant technology using CO2 is being considered and probably under development. I don't know that any are out and yet available for heat pump installations for air source or ground source heat pump installations.
Someone else asked, do you need a water pump for every sink, or can you use one for two sinks that are in the same bathroom?
The water pump circulates water, the one that I showed, circulates water through your whole system. And the way they advise is that you put that at the most extreme sink in your home, and it'll typically circulate the whole water system in the home that way.
Okay.
So you only need one, most likely.
Okay, someone else said, not all pots and pans work with induction ovens, but if a magnet will stick to a pan, it'll work with induction.
Right, and the induction stovetops require typically a steel pan and with a heavy bottom so that they don't get warped. Cast iron works, but otherwise stainless steel. And if you've got a copper bottom or aluminum or some other sort of pot or pan, you won't be able to use it on an induction oven. So when we got ours, we did invest in a few extra pots and pans.
Someone asked, we have a gas water heater that only runs in our floor heating. Oh no, I already asked that question. Never mind. We have 6-inch stud walls in our 1987 built home. Any idea what kind of R value that would be?
Not remembering off the top of my head, but I think a bat in a 6-inch wall stud are rated at an R value of 12, but I'm not sure on that. I think you could probably Google that and find out.
Someone asks, I live in a townhouse condominium. It has room for solar panels, but because it's a condo, I don't own the roof. Do you know of any condo associations actually allowing solar panels?
I don't know of any, but I wouldn't be surprised if there are some. It also depends on how your homeowners association works.
Mhm. Okay, so I think those are the questions that are in, have been in there. And if anybody wants to raise their hands to ask additional questions, go for it. Catherine?
I wanted to know what the R value of the rigid board rock wool that you used and approximately how thick it was.
It comes in different thicknesses. The 2-inch thickness that we use has an R value rating of 7, and a 3-inch, I think, has an R value rating of 11.
Court, could you take down the thing so I can see people better?
Sure.
And Barb has a question.
Well, before I close down the
okay.
screen, I just want to make sure everybody remembers the big picture. There's urgency involved here in what we do about the climate. Group advocacy for government action is really, really critical. Though it's important what you do as an individual, the most important thing you can do is help support group advocacy at the government level. And then make a long-term plan for cutting your home's carbon footprint. And with that, I'll close out my sharing. And my goodness, there's still a lot of people left. I'm appreciative of how many people stuck with this.
Yeah. Okay. Barb's got the next question.
Okay. My question is, you had said that you had to upgrade your electrical panel when you got your heat pump. What did you have to upgrade it to? How many, whatever?
Well, we actually upgraded it before we got the heat pump, because we put our electrical service underground in the front yard and did a tiered wall landscaping of the front yard. So at that time, I knew that I'd be needing more panel capacity, so we upgraded. And to be honest, I don't recall, because it goes back now about 9 years. I don't recall what we went from and what we went to, but everybody I know who's made the heat pump transition off of a gas furnace has reported that they had to upgrade their panel. You just have to, it depends on what you've got now and how much that'll cost and what you need to upgrade to. But make sure you think about all the options. Like, are you going to want to put a battery pack in? Are you going to want to have an EV plug in? All those things come into play, and that'll affect the expense. I know Catherine, if she's still on, recently has explored that, so she might be the most expert in the room at the moment.
I'm happy to talk to that if people want me to.
Sure, go ahead.
I have a relatively modern house. It was built in 1984. Originally, everything was electric, and then some owner prior to me considerably switched the furnace and the hot water heater to gas, and the circuit panels, the breakers, then got repurposed for other purposes. So when I looked to what it would take to get it switched back, the furnace and the hot water heater back to electric, a couple electricians looked at my panel and said, even though it's 200 amps and we think that capacity will serve you well, the physical size of the electrical panel was too small. So it was a very compact panel. And so I just upgraded it to a much larger panel with the same 200 amp capacity so that I could have an electric furnace, an electric hot water heater, and electric vehicle charger.
Yeah, memory serves me that that's what we got as a 200 amp service, but don't quote me on that. It'll depend on your home size and all of your other electrical load.
I want to acknowledge that we are definitely over time, and I figure you're all adults. You can leave if you need to leave, but as long as people are asking questions, I'm just going to let them ask questions so we get great answers. And I have another one in the chat. It says, how much is the energy savings between regular and tankless water heaters?
Don't have an answer for you. The water heaters themselves or the operation, I don't know the answer to either question, but the tankless water heaters are going to be heavy energy draws because of their nature. Whereas a heat pump hot water heater, as long as you've got that circulating motor, it's going to give you that instantaneous hot water and at a much lower energy expense and probably a lot less energy bill.
Okay, another question, between probably very poor insulation in walls versus putting in an electric heat pump to replace electric wall heaters, which is going to be the better first step?
Well, I would say if you know you don't have insulation at all in the walls, it's
Well-
not very expensive to get cellulose insulation blown into those wall spaces. So I would recommend doing that right away, and that'll save you potentially in the size of heat pump unit that you need to put in. And if you've got baseboard heating, you're going to want to use the ductless heat pump systems. And you need to think about where to put those indoor units, because they will be localized to wherever you put them in. And you certainly want, if you got multiple stories, you want one on each floor. And if you've got a long house, you may want one at each end of the house, because they'll only do the heating or cooling in the room that they're sitting in, and that air needs to flow to adjoining rooms if you want the adjoining rooms to be affected.
How much of a problem is it then when people don't have open floor plans, when they have, kind of doors to every room?
Well, I've heard people explain when they do that, they leave the doors open to the rooms, and they selectively put the new interior heat pump wall units in the rooms they most want to control. For example, you may not be as concerned about heating your bedrooms since you're not in them most of the day, and yet you are in your living room and family room, dining room, and so forth a lot. And that's a more important place to locate a indoor ductless unit. But you might put them in a couple places.
I knew someone who believed it was impossible to put a heat pump in their home because they said they didn't know where there was wall space to do that. Is that really an impossibility for some home designs?
Well, unless your home is all glass completely, wall to floor to ceiling, there's got to be a place where you can put them in the wall.
Okay, thank you. All right, folks, anybody got any more questions? Catherine's got her hand up. Go.
Okay, it's a philosophical question that you were kind of touching on, Court, and I feel like I need to ask this after I undertook my electric upgrade and started penciling out some of the costs of this. Are you suggesting that we might instead take the money that we might be using to reduce our home's carbon footprint and instead spend it on climate change activism or whatever, funding government, things that might make, PACs for climate action or something?
No, I didn't mean to suggest that activism needs to cost money. It does cost time and energy of your own personal schedule. So that's what I wanted people to make sure they stayed attentive to. We need a lot of voices to really carry the planet where it needs to go. And if you stay silent, we're not going to get there.
So you can use your voice in one place and your money in another.
Right.
Okay, thank you.
Okay, I'm not seeing more hands up. I want to remind people that my email address is in the chat, and if you want to get a link to this later, because it will be posted later, you can email me about getting the link to that. Also, a reminder that both groups, FACT and Olympia Green Faith, will be holding workshops in the next few months about how to do personal divestment, how to divest from the financial institutions that are funding our fossil fuel companies. And so if that's of interest to you, again, you can email me so you get invited to one of those workshops. So thank you all for spending a great deal of your evening together. And if you want to unmute for a minute and clap for Court.
Well,
Yay!
yeah, I'm surprised so many people stuck with my long drawl.
Well, really most of them made it all the way through your presentation. Once questions started, we did have considerable drop off.
Sure.
So,
Well, thank you, everyone. I'm glad there's so much interest, and good luck in making those plans for your home.
Good.
Have a good
Okay.
night.
Good night.
Bye-bye.
bye,
Good night.
bye-bye.